Hi guys, welcome. Today we are going to talk about rules for exponents. If you watched the video from Tuesday, you probably have some idea of how the exponent rules work. But since it wasn't my own personal video, I'm gonna post one today recapping those rules, all right? We're going to start with a little bit of vocabulary, all right? So these are the parts of the exponents that you need to know. There's two main components, which is the base, which is the larger number, and then the smaller number, which we call the exponent. And the whole thing together is called a power. And so what the exponent does is it tells me the number of times to multiply the base. So for instance, 5 squared, I know sometimes when we see exponents, people think that the answer to this would be 5 times 2, but that is wrong, and they get 10. 5 squared means 5 times 5, so you want 5 2 times, and so the correct answer here is 25, right? So that's how an exponent works. It tells me how many times to multiply the base by itself. And so we're going to look at some different exponent rules for this. First one we're going to look at is the product of powers rule. Right, a little bit of vocabulary there. When we see the word product, right, we're not sure. Product means to multiply. So we're trying to figure out what do we do when we multiply powers. So this rule here says that if you have a base to a power times another base, the same base, right, and that's important, it has to be the same base, then you're going to add the exponents. So we're going to take a look at what that looks like. So here we have 5 squared times 5 to the 6. So we already discussed just a moment ago that 5 squared means 5 times 5. And then we can rewrite 5 to the power of 6. That means 5 6 times. So this is 5 squared, and then all of this is 5 to the power of 6. Well, if we multiply that all together, what we really end up with is we're actually multiplying 5 a total of 8 times. So this is really 5 to the power of 8. And so what the rule says is if you are multiplying and they have the same base, then really all you're doing is adding together those exponents. 2 plus 6 is how we get 8. So when you're multiplying, you want to add your exponents. Okay, let's take a look at number 2 here. We're multiplying multiple things together. I'm going to start again by expanding it. So we have y to the power of 4, which means we're going to multiply 4 y's. That's y4 times y3 times y. And if we don't have an exponent there with that y, that just counts as 1, so that's like y. Well, I should put it here. That's like y1. And so what happens is if we count all of this up, really we have a total of 8 y's. So the answer for this would be y to the power of 8. And we could have used a shortcut to get that by just taking our exponents, 4 plus 3 plus 1, and we would have gotten 8. And so we can use this rule of adding the exponents instead of drawing this out every single time. So this is like a shortcut to the product rule, right? So I'm gonna try it this time, but without expanding. Now, when we see this adding part only works for the smaller values, just the exponent. It doesn't apply to the coefficients. So when I multiply this out for this example here, okay, this is like saying 7 times y5 times 6y. And so what I can redo is I can write this is like 6 times y. I can rewrite this as 7 times 6 times y, 5 times y. And so the number part of this, 7 times 6 is 42. And then we just found that if we are dealing with exponents, we can just add them. So this would be 5, and we will count this one as 1. So 5 plus 1 would be 6. And so then that would be our answer here. So we still have to multiply the 7 and the 6, but for the exponents, we add them. Okay. Let's take a look at one more. This time we have multiple variables. So this means -3 times x squared times y7 times 5 times x, and again we're going to put a 1 if it doesn't have an exponent, times y6. And then what I can do is I can rearrange all of this. So that's going to be -3 times 5 x2 times x1 y7, y6. And now I can simplify this, so we're going to end up with -3 times 5 is -15. And if we add the exponents here, 2 plus 1 will give me x3. And then for y, 7 plus 6 is 13. So then that ends up being our final answer here is -15, x to the power of 3, y to the power of 13. Because again, using the shortcut for the powers, we're able to just add them. So 2 plus 1 is 3, and then 7 plus 6 is 13. Okay, and that is how we would do the product of powers rule. In the next section, we're going to take a look at the quotient rule, which is the opposite. So product means what to do when we are multiplying. Quotient is going to be the rule for if we are dividing. All right. So the rule here says that if we are dividing, then instead of adding our powers, we are going to subtract them. Right? So if I expand this first, we'll see why we need to subtract. Again, y to the power of 6 means I'm multiplying y times itself 6 times. And of course, nobody's going to want to draw this out every time, which is why we're going to want to use the shortcut. All over 1y. Well, we know from before, whenever we're simplifying, if you have the same value on the numerator and the denominator, they cancel each other out. So that y is going to cancel out, and then I'm going to be left with only this, which is 5y's. So my answer here is going to be y to the power of 5. And if I were to use the rule says it's the y, which is the base, and then 6 minus, and again, if it doesn't have an exponent, you give it a 1. 6 minus 1 is how we would have gotten the 5. Okay? I'm gonna try that here. Now this is why this is handy, because this is 6 to the power of 13. Now I could draw out 13 sixes, but again, no one wants to do that. We really don't have time for that. So what I'm gonna do here is I'm gonna use the rule. The rule says to keep the base, so our base is 6, and then we're going to subtract, and you subtract the numerator minus the denominator. So this is the 13 minus 2, and so the answer here would be 6 to the power of 11. All right, pretty simple. All right. So again, we can only do that if they have the same base, then we're able to subtract. So we look here at this last example, we have a lot of different bases. We can only subtract things that have the same base. So the number part we keep the same. So we have 10 over 15, A7 over A5, or A to the power of 5, I should be saying. And then we have B to the power of 9 over B to the power of 9. And so when we see this does not mean subtract. This is just a fraction. So the only thing that we can really do with a fraction is we can simplify. So 10 over 5, it doesn't divide evenly, but we can simplify it. We can divide these by 5. And so that's going to give us 2 over 3. And then if we subtract our exponents here, so this is going to be a. So we have 2 over 3, and then we're going to have a to the 7 minus 5, and then b to the 9 minus 9. So we're going to get 2 over 3, a squared, and then 9 minus 9 is 0. And so we're going to get b to the power of 0, which means that there are 0 b's, so then we don't need to write it. And so this would be our final answer, which is 2/3 a squared. All right, so far we've seen what to do when we have multiplication of powers. Remember, when you see quotient, quotient means that you are dividing with the powers. Now I'm going to take about the 0 rule. So you guys just saw there that we had in the last one 9 minus 9, it became 0. And this rule is fairly simple. It says that any non-zero number with an exponent of 0 is equal to 1. So that means that anything to the power of 0 is going to be equal to 1. And so what happens here is, remember we talked about in the quotient rule that if you have the same thing, the numerator and denominator, this would be 8 to the 2 minus 2, which is 8 to the power of 0. And we know that anytime you have something over itself, this is just one whole. So this means that one whole is equal to 8 to the power of 0. So anytime your exponents cancel out and you get 0, it means that your answer is going to be one whole. Okay? So what that looks like in an example is, here we have this whole thing set to the power of 0. So the whole thing is to the 0 power. So this would just be equal to 1. Now we have to be careful on this side because the whole thing is not to the power of 0. The only thing that's to the power of 0 is the x. So this is like 8 times x to the power of 0 plus 5. The 8 and the x are separate, and so the only thing that is to the power of 0 is this. So only this part is going to become 1. So this is going to be 8 times 1 plus 5. And so 8 times 1 is 8 plus 5 is 13. So the answer here would be 13. Okay? So that is the 0 rule. Pretty simple. Just if you raise something to the 0 power, it becomes 1. If the whole thing is in parentheses, that means the whole expression is to the 0 power. So everything turns into 1. This didn't all turn into 1 because it wasn't all in parentheses. Next, we're going to talk about a negative exponent. All right, so the negative exponent rule says that if you have a negative exponent, we get rid of the negative exponents by turning this into a fraction and moving it down to the denominator. All right, so you're going to place the power in the denominator to rewrite it with a positive exponent. The reason this is, again, if we take that quotient rule and we were to expand this, this would like 2 b's on top and 5 b's on the denominator. And so what's going to happen is these are going to cancel out. And so what we're going to be left with on the bottom is b times b, which is b cubed, and then there's nothing left on top, so we put a 1. This is the same thing if we use the quotient rule from before. Remember, the quotient rule says to subtract them, so 2 minus 5 is equal to b to the negative 3. So that means that these things are the same. What's going to happen is when I cancel, I'm going to end up with more b's on the denominator. So that means that the negative 3 represents the 3 that are in the denominator. So these two things here are the same. So when we have a negative exponent, we move it down to the denominator and it becomes positive. So what that looks like here is 2 to the power of negative 3. We take a fraction and we move it down, so it's going to be 2 to the positive 3, and then we put a 1 on top, because that's what it says. It says you put 1 in the numerator, and so we would get 1 over 2 to the power of 3. Same thing here, if the whole thing, and then we could work this out, right? So this is 1, and then 2 times 2 times 2 is really just 8, so we could say that that is 1 over 8. And then for the next one, the same thing, this whole thing is inside parentheses. So we make our fraction, put 1 in the numerator, we bring that down, so it's going to be negative 3, and now it's the positive 3, and so this would really be 1. You got to be careful here, that's negative 3 times negative 3 times negative 3. So we have a negative times a negative is going to make a positive 9, but then when I multiply it by a negative 3, it's going to make negative 27, okay? But again, when we turn that into a fraction, this negative comes down to the bottom and it becomes a positive. So the idea is that we want positive exponents, so we take the ones that are negative, move them to the denominator, and they become positive. And when we do that, we have to put a 1 in the numerator to hold that space. And that's what the rule tells us here, that we put a 1 in the numerator. All right, almost finished. We have one last rule that we're going to cover, and that is going to be the power rule. Power rule kind of looks like the product rule, but it's a little bit different because we only have one base this time. And so what we do here is kind of going to think of this as a stamp, okay? The power rule says that if you are raising a power to a power, then you must multiply the exponents. So this tells me that I want x to the squared, I want that 8 times. So I'm gonna first expand it to show you what that looks like, and then the next one using the shortcut. So this is my image x squared, and this tells me that I want that 8 times. So that's going to be 1, 2, 3, 4, 5, 6, 7. So that's 8 times. And then we know that each one of these represents 2 x's. So that'd be x, x. And you can see where I'm going here. Each one of those is going to produce 2 x's. And so after we do all of this, we're going to end up with, as you can see, a total of x to the power of 16, all right? X to the power of 16. So instead of doing all of that, the shortcut says, hey, all you need to do is just multiply the exponents. So what I could have done here is use that shortcut rule use a shortcut and just multiply that and say that this is equal to x squared times 8, which is x to the power of 16. And that's what I'm going to do over here. So we have y to the power of -3, and I want to raise that to the power of -4, so I'm going to times that by -4. And then this kind of works out because the 2 negatives are going to turn that into a positive exponent, which is good because we like positive exponents. So it would just be y to the power of 12. Okay. Same thing here, even if we have multiple bases, if we have multiple pieces to our power, we're going to find the power of each factor in the parentheses and then multiply. So that means that everything in here has to go to that power, right? So again, think of this like your image, and this says that I want to raise it to the third power. So that would be like multiplying this thing four times, right? And then I would multiply all of that together, and I would get my answer, right? But the shortcut says that we can just take each one of these things and raise it to that power. So instead of doing that, I'm going to take everything that is inside of the parentheses and raise it to the power of 3. So that would look like this. So we start with a 4. I'm going to raise that to the power of 3. Then we have x3, and I'm going to raise that to the power of 3. Then we have y, I'm going to raise that to the power of 3, z to the power of 3. And so now everything in here has been raised to the third power, and now we need to simplify. 4 to the power of 3 means 4 times 4 times 4, which if we do a little bit of math, that's going to be 64. And then here we're raising a power to a power. So when we do that, we're going to multiply. So 3 times 3 is 9. So we're going to get x to the power of 9. And then these didn't really have exponents. The exponent was 1. So that's going to stay y3 and z3, or y cubed, z cubed. And then that would be my final answer. My final answer would look like this. We took everything in there and we raised it to the power of 3. Okay, let's try that again. All right. So we want to raise everything in here to the power of -2. So it's going to be 7 to the power of -2, x to the power of -2, and then y -2, and we raise that to the power of -2. And so what we're going to end up with is, now we have our negative rules that we need to use. So if this is to the -2, and we put 1 over 7, and that goes +2, and this is going to be 1 over x to the +2. But then what happens here is the two negatives are going to turn into a positive when I multiply, so that's going to be y +4. And then there's nothing on the denominator there. And so now what I can do is I can simplify by multiplying this all together. So anything times 1 is going to stay the same. So on the numerator, we're just going to have y4. And then on the denominator, 7 squared means 7 times 7. So that's 49. And then we have x squared. So then that would be our final answer. It's going to be y to the power of 4 over 49x squared. Okay. All right, here we go. One last example, and then we're going to wrap this up. Here we want to raise everything to the -2 power. So everything inside, starting with that 6. So we're going to have 6 to the power of -2, x to the -6 to the -2, y to the -7 to the -2, and z0 to the power of -2. And then this is a negative exponent, so we're going to put 1 over 6 to the +2. And then we need to multiply our exponents to see if they turn positive or if they stay negative. So this is going to turn into a +12. So it's going to be x12 with nothing in the denominator. Here we're going to have y +14, nothing in the denominator. And then 0 times anything is going to be 0. And then we said, well, we'll just put that here, z0. So we can simplify a little bit. So on top, we're going to have 1 times x squared times y to the 14. And then what's going to happen here is that z to the 0 is just going to become 1. All right, so that's like a 1. So all we end up with in the numerator is x to the power of 12 and y to the power of 14. And then in the denominator, we have 6 times 6, which is 36. And so this ends up being our final answer, is we have x to the power 12, y to the power 14, and then in the denominator we have 6 squared, which turns into 36. Okay, that's where we're going to stop today. I know it's kind of a long video, but these are all of the rules, and you should have seen these again last video on Tuesday. I will be hosting a live session today with the same information, and there are going to be questions that you need to answer today in the Schoology page, so make sure that after you watch this video you go in and do the assessment for today. All right, live sessions are every week, Tuesdays and Thursdays, so if you need additional help, make sure you live. I start at 10:45 on Tuesdays and Thursdays. All right, so hopefully I'll see you today at the live session.